to basically get started, let me add the link here as well. So that's our current, and here installing USD View and setting up Python. That's the installation you have to do, because this gives you a directory which you unpack into C USD root, and there's everything you need to have with exercises and all the USD Pixar USD stuff, right? And the exercise itself, it's just based on Pixar USD, but we ourselves also use Omniverse Composer, and we switch basically between USD View and Omniverse Composer. Right. So I'm using Cursor myself, but you can also use VS Code. So as I said, also these exercises, they have their own exercise kit, a zip file, which you also have to download and unzip into the same folder. Here we have instancing exercise, and that's basically extracted here. USD road instancing. Okay. So let's open the folder here. USD root. And go into our learning path. I think the last time we ended here in refinement using variant sets, right? I guess.
Yes, that's right.
Yes. So basically, yeah, we created different variant sets, and USD created like two prototypes, I guess, from the for the instances. Yeah. And we've also seen that yeah, the scenes statistics will reflect that instances and prototypes. You know. So yeah, I'd say let's go to hierarchical refinement. What's hierarchical refinement? Refers to the process of refining instances by authoring inherited properties on ancestor prims. The most common inherited properties used for this type of refinement are transformation operations, visibility, and prim vars. Okay. Importantly, these refinements do not create any new prototypes. They simply leverage inheritance to efficiently introduce variety or control across instances. Okay. Primvars. So you can derive material properties like color, but it's not limited to just that. Convenient feature about primvars is that they inherit down the prim hierarchy. This means is that you can set an opinion for primvar on the instantiable prim or any ancestor, so any child, right? And your materials can read that inherited value at any point, and in the subgraph, you can use primvars to hierarchically refine instances. Doesn't introduce new prototypes, since the subgraphs among the yeah, the subgraphs remain identical because like they just reference the primvar from the upper level, right? So yeah, that's cool. And your only opinions are found on the instantiable prims. Exactly. So these guys, right? This makes Primrose a very lightweight way to introduce a ton of variety in a scene with very little performance implications. Let's look at the concrete example of hierarchical refinement on Primrose. So what do we have here? We have a warehouse. We have 3 robots, right? All are instantiable. And they have a reference on this robot arm. Robot arm is basically, right? And so here we set the Primvar arm color to some, what is it, like RGB, that probably. And Primvars, yeah, that's another a reddish thing probably. No, it's what's the green one, right? That should be this one, yeah. Okay, to change the color to robot arms as it has a shader to read the value and use it with the material network. Yeah, so basically in the, you see, we don't have any shaders here because the shaders are actually in the robot arm, and they reference basically just, they say we need an arm color which comes from somewhere else probably. Yeah, and we set this into here our prim, parent prim. Yeah, it's cool. So any questions so far? Should we go to the exercise? Go to the exercise. In this exercise, we're using Primvars, efficient RAM technique, then blah, blah, blah. You use a custom cleanness Primvar to control material appearance. Observe how Primvars inherit through the hierarchy and understand why approach has minimal performance impact. Makes sense. Yeah, probably just change this one value, and the other thing is in the instances. Okay. We are going to a custom cleanness Primvar that we authored for our box asset to control the brightness of the box cardboard material. In simulation, we would use this as a visual representation how long a box has been in a warehouse. Yeah, makes sense. All the box would appear dirtier or darker than the rest. This would enable us to quickly scan our digital twin and find boxes that have been sitting around for a long time. Okay, let's check this out. Yeah, you can go on Windows or Linux, all those other guys, right? I'm just terminal. I don't like the nice common prompts. Firstly, as always, we have to activate our environment. So we have our Python USD virtual environment, right? And now let's load our viewer. I'm just on battery, so it's probably a little slow. Okay. So click on the top left box in the viewport. Yeah. Top left box in the viewport. And we have selected probably this guy. Yes. Click the triangle to Prince hierarchy. Click the triangle to the left of the looks in the tree to expand the Prince triangle. We did that. USD Primvar reader cleanness. Where is this? Which one is it? Looks cardboard 01. Okay, yeah, it's in the looks, yeah, sure. Makes sense. That should be this guy. Yeah. Did you find it as well? Cleanest. Shader is used by, so that's the input var name. Yeah, that's it, cleanest. That is used to all boxes, check, and then G prim, that's assigned to it. Okay. Click on your student selected, and from this, attribute expanded. Yeah. USD preview surface. Where is it? USD premier surface, and what is it? Is it the? My brain is just inputs occlusion. Inputs occlusion. Yeah, makes sense. And oh yeah, see. Output from cleanest is connected to input. Yeah, probably. To drive the occlusion, the closer the number gets to 0, the darker the material gets. Okay, makes sense. So, setting the primer values. Let's see the custom primer action boxes. So we change now that basically the primer value with the Python interpreter in the USD view. What happens? We get like the stage, we get the box, one box, and the other box, and we make the cleanness we change the cleanness parameter basically, right? So let's do that. So here we go, window, interpreter. We get our interpreter. That might be on another screen or something. If you don't see that, just look around and you'll find it. So I've pasted this, and now we expect to see those guys to get darker, right? Yeah. Dark. Not so dark, but still darker. Great. Any remarks or questions? Very good. So let's analyze the impact using stage statistics, run the code in the interpreter. So yeah, we always use that to see how we got with the prototypes and the instances. We got a lot of info about the scene complexity. Let's do that. Yeah. 1450. Now I'm just driving through the tunnel a little. Maybe the connection will be broken, but I'll be back. 1450, 1450. See that? Yes. Primer refinement does not add any Yeah, because we just basically change values for a shader, so it doesn't affect any triangles or any trims at all. All we are doing is altering a new opinion on the instantiable prims that are already part of the total prim cut. Yeah, no new prototypes are created either, because yeah, it's just, yeah, it's the same shader, but just different values, right? The single prototype handles all the shading variability on its own, and that's really a good thing. You know, that's pretty performant. Refinement for the visual variety. Yeah. Did you guys use that already in some project or something? I didn't, but that's not also like seems very performant. Great. You've successfully leveraged hierarchical refinement using Primwas, an efficient technique for introducing variety in the scene. By leveraging Primwas and material networks, you create extensive scaling performance penalty. Yeah, that's good. Especially for large scale scenes, I think you can do like a lot of variability without performance loss. So that's cool. Yeah, I like that. Great. So if there are any remarks, I'd go to the ad hoc arc refinements. And I think, yeah, for the new guy members, we're pretty advanced already. So if you don't get along, just like, yeah, try to catch up reading the USD learning path, and yeah, if you have questions, just reach out and ask it, right?
Yes.
Yes. Yes, Ralf?
Excuse me?
Did you have any a remark or something? No, I just okay, got it. Okay, so what is ad hoc arcs refinements? Composition arcs can be added to an instantiable prim on the local layer stack with the additional content. Yes.
Michi, maybe we should just very briefly say a word about composition arcs. Yeah.
Yes.
So Sergio and Andre, have you heard about composition?
Yeah, Jan, if you like to say a little something, or should I just read that?
Your mic is off, Jan.
You didn't hear me at all?
Now we can hear you.
Okay, good. Just a very quick intro onto composition arcs and OpenUSD in general, so that you have a better understanding what the hell we are talking about. Is that okay?
Yes.
Yes.
Okay. So OpenUSD is originated from Pixar. Pixar being a big production firm, and they had the issue, lots of people working on the same movie, and they had to organize their 3D stuff across different departments, different people and different tool chains, pretty much. So they had to come up with a unique 3D description language, which is on the one hand describing the scene, and on the other hand also enabling them to do pipelining. So it's describing and it's also generating at the same time. And in order to have the ability to have non-destructive workflows between different groups, they came up with a system of layers where you can layer your geometry and then other stuff on top of it. And this in itself is called the composition arc, and it's called liver piece. So if you ever come across the term liver piece, it's the composition arc, and that is what this is all based upon. And if you can see my cat in between here, so that's it for now.
Okay.
Just to give bigger frames. Yeah.
Great, thank you. Also here the composition arcs. That's here the whole section, right? And yeah, liver piece itself, it's just to remember the different how do you say, like elements and its strength. So yeah, that's one of the core elements of OpenUSD. So you have to really be look into that, right? And it's super powerful. So Aaron Luke also talks about like the USD superpowers. Yeah. So yeah, where have we been? The ad hoc arc refinement. There we go. With the additional composition arc, you can introduce new opinions on an instance. The result is a new prototype for that instance and any copies that share the new composition arc. So, yeah, okay. We have a class refinements and we do like an overpose over this joint. We do a new, it's interesting, yeah, okay. So basically we reference the refinement as a, the new value of this, right? Okay. In this example, we have 4 instances of the robot arm. On one of the instangible prims, we can add a new internal reference with a different pose for the robot arm. The result is 3 instances using the original prototype and 1 using the new prototype with an additional internal reference. Nice. The more instances you apply the new composition arc to, the more beneficial and appealing this technique gets. In this example, a dozen or so robot arms using the same pose can make this technique worthwhile. So if you want to like change a lot of, like, you have a lot of instances, but want to change also quite some subset of them to the same values. If you don't foresee a lot of instance leverage in the ad hoc composition arc, the de-instancing may be a yes. So the de-instancing, we had that two units before. That's basically just setting an instance to not. You can read it basically. But it sets the instantiable to false and changes the value of the attribute. That's also a possibility, but and here we basically just put the change we want to do in another in a class in this case, and we put that into our instanced things. Yeah, that's quite I think advanced. I know. Did you guys use that as well yet? Anybody? No. So yeah, let's try that. In this exercise, we'll learn ad hoc refinements technique. That's we just read that. You'll add stamps boxes with the word damage using internal references. Observe how this creates new prototypes and understands when this approach is most beneficial compared to other refinement techniques. Yeah, that's good. Similar to boxing, we tried. So okay, open instancing source assets utilities. I'm just gonna be using VS Code and inspect the USDA. So I'm using my cursor for that. Sensating. Source assets, asset utilities. Source assets, asset utilities. Misspec paths, right? Yes. You should have that as well here, right? Yeah. Over damage stamp. And that's kind of material bound to there. We have, well, let's see what they tell us. mixing overrides is a speculative over and introduces a new decal mesh and material from the damaged stamp. This is a bit hard-coded to position the stamp perfectly on the Q box asset, but it could be designed to be used more modularity, so it could be applied to the sorts of assets. We're going to use this layer as a reference to refine our boxes as an additional ad hoc composition arc. Okay. Yeah. Great. And my daughter just has arrived at our first driving on herself by herself. So congrats. So let's look at that. I just, yeah, maybe. So, yes. Still have enough power, I guess. I hope so. So, yeah, we open the scenario and run this code. Hier schon mal eine. So we have to wait. Oh, come on. No, that seems to be a very like complex scene, right? Oh, it's the same. So, okay. Run the following reader window. What does it do? No. Okay. This code overrides the top first and second boxes on the palette closest to the camera by adding a new reference to mesolential decals on the incentrable prim. Notice how the top first and second box on the palette closest is now show a stamp that says damaged. So we should see here a damaged stamp. Yeah, let's try. Reader. Where is it? There we go. Things happening. It's probably a little, yeah, I'm on power save mode probably. No, does anything happen? No, not yet. Do we see anything? I don't see anything. Yeah, but I just selected it. Yeah, that's just maybe which one did we camera, select camera, XCam1. We already have that. Which one did we change? Yeah, that's that was what I would expect, but I don't see it, so that's strange. Let's see, what did we do here? Reference. Which one was it? Rack box palette A1. 3. See, and it should look like this actually. Damaged, right? If I see that correctly. Okay, so let's see. Which one did we edit? Warehouse rack box palette AL1. That guy. Box palette. A13. No, what was it? Box palette A101, box palette. That should be this, no? Yeah, that guy. That one. A426 17 and 18, right? So I did 17 and 18. Equals box 1, get references, add reference. So we should see reference, the references here, right? Where is it? Position, do we see anything here? No. There's tag as well. No. No, and I don't see anything, right? I'll just open it with or do you see anything? I'm just didn't do anything, I'd say, right?
I see 2 stickers damaged in my scene.
Well, oh, do you want to share it? Use your screen?
Yeah.
I don't see it yet. I just saw it briefly, but it disappeared again. Maybe if you could share it again. Yes. I got also like some
Do you see this?
Yes.
Yeah.
We see the USD code. Oh, it's gone again. Yeah.
So I should see some my view.
Yeah.
And this,
Yes. Yeah,
Yeah.
that's how we would expect it. And And I also saw in my console that there was a program fault. So maybe my laptop on the power save mode, or I don't know. But that's how it should look like. Yeah.
yeah, I executed in the interpreter.
Yeah. Same.
Okay.
So
Yeah.
that's awesome. Yeah.
Yeah.
That's how it looked like.
Okay.
Should look like.
So I close.
Oh yeah,
Or
yeah. Maybe if you if we can switch back again to the
Okay.
USD course, And then if you do the changes and show how it turns out, I
Okay.
think that would be great. Yeah.
Mhm. Okay.
So and I also try to open a composer to see if that's showing maybe a difference. Yeah. In the meantime, oh, that's interesting. Yeah. Okay. Yeah, I think my laptop is just giving up on this. Right. So let me share my screen again. Yep. And there we go. So basically, yeah, what we saw at Andreas, we just put the decal here on these boxes, and yeah, if you can also run the statistics, maybe, Andy, and verify that it's like it has created a new prototype, because yeah, these two differ, right? In this decal bump sticker, so we have a prototype more. But it's still cool from OpenUSD that it just determines like how many, what are actually the prototypes, and it takes care for that by itself. Instance count is the same. Prototype created to 4. Instance a new comment on instance trigger the creation of a new prototype with the modifications that we defined in the new arc. Yeah, I would see it as like as a change set we put to certain instances, I'd say, by using the composition arc. Yeah. This technique is most beneficial when you may have instances that will use the same ad hoc composition arc. Yeah, that's changing like a subset of the instances, I'd say. Yeah, but still, yeah, I'm also not familiar too much with that. Yeah, Andy, could you like verify that? Did you have also this result? Are you muted?
I just did it.
Uh-huh.
I share.
Uh-huh. Great. Oh, we see something. Yeah. Uh-huh. Oh, it's a little small. Does it say like 4 prototypes somewhere? I can't read it.
For prototype count 4.
Mm-hmm.
Mhm.
Yeah. Awesome.
You need other values.
Oh,
instead of-
I think that would be, yeah, that's basically the thing that the type yeah, was increased because we added like this decal. Yeah, I
Hmm.
think that's
Okay.
great. Thank you. So yeah, maybe let's then just briefly look into the next, or any other remarks or questions from you guys. So share my screen again. And we come to broadcasted refinement. broadcasted refinement leverages the special broadcasting ability of inherent and specialized. Yeah. That's some of the most, I mean, especially the specialized arcs. For me, like it was like the hardest part to like get my brain around when things change. What I don't know about how you guys, but yeah. These two arcs are built for downstream refinement, allowing you to author new opinions on the inherited or specialized namespace in any downstream layer stack. All prims with an inherit or specialized arc targeting that namespace will receive those opinions and applying them according to liverpiece. Yeah, and that works on instances too. So what do we have here? We have a lot of overs, right? And we put an we rotate basically the joint one now. In this example, both robot arms in workcell 2 inherit from Mer's shared robot arm, and the robot arms in workcell 1 do not. As a result, when we author an opinion in the workcell 2 shared robot arm namespace with a new post, the opinion is broadcasted to robot arms in workcell 2. The robot arms in workcell 1 keep the original poses. The result would be a new prototype shared among instances that received the new pose. Yeah. So I think, yeah, we just have 9 minutes left. Should we? Well, let's just look into the exercise and go as far as we can, right? And also my battery. How long does it take? I don't even see it. It's also like 10 minutes, so probably, yeah. Oh, come on! Maybe I shouldn't have started the composer as well. Okay, but you still hear me and everything, right? So yeah. Yeah. So in
No.
Maybe the battery died now.
Sooner.
But he did get home safe with his daughter, right?
Yeah.
He was standing.
Yeah, he died. No, his battery is dead.
Yeah,
I
already. Only
I
5
wish you a
minutes
good
left.
weekend.
Yeah, you too.
Thank you.
Nice weekend.
Bye-bye.
Anybody
Have a nice
before we
weekend,
leave?
guys.
Is anybody going to Hannover Messe?
Yep.
I don't, maybe. You will
Okay.
there, Jan?
So Ralph, yeah, I'll be there. Yeah.
Are you there on Monday, Jan?
Tuesday, Wednesday.
Ah, okay. So you might meet up with Bernd. He's gonna be there on Tuesday.
Okay, good.
Sorry, I just
Yeah, he's
lost
He's back.
my laptop. Yeah, I'm just came through the telephone. I think my
my laptop is running out of battery. It just doesn't do anything anymore. So I think yeah, if you, I think we continue with the exercise the next time. If you have any other remarks or should we do something else or some on the especially also the new guys, if you want to say something, yeah, go ahead.
I've seen that you have uploaded some recordings behind, so I
Yes.
will start watching them, and I will hope I will can catch up.
Yeah, sure. Maybe also I thought about like if we do some, if we do a do like 40 minutes maybe with a study path and 20 minutes just like looking into some things you do and where are your if you want to show something or that would be also maybe an idea. That we just not only go over the learning path, but also yeah, look into something else. If you'd be interested, you know.
I understand. Okay.
Yes, that is what I will ask. If it's possible to stretch the agenda a little bit, that we have a little bit time for open discussion or
Yeah,
show
sure.
something or ask something. So that is the reason I'm participating in this meeting to talk about the stuff. So not all the
Yeah,
time learning, it's cool, but I think the platform is so huge, and I think it's a very good place here to share or talk about or ask questions
Yeah.
how other peoples can do things.
Yeah, and that would be great, I think. Yeah, just not, yeah. So do you have any like an issue you want to raise or already have something in mind?
Me?
So
Ben
Benjamin,
or I think Ben would.
What is the question?
If you already have like something in mind you want to raise or a question or some.
Today I have not. I must leave in 3 minutes. So for
Okay.
today, sorry, it's not enough time.
Yeah.
If the meeting is each weeks or
Yes.
okay,
Each
perfect.
Friday. So
Okay,
yeah, maybe we start next time with yeah, just general part with like 20 minutes or something. Yeah. And
so what
you guys bring what do you want?
what I would be interested in from you, Benjamin, since you've got this virtual commissioning, what do you solve within for next time? What do you solve within Omniverse, and what do you solve with other tools that you bring into Omniverse?
I can share you a lot of things next week, no problem.
Yeah.
So yeah, I invested last 20 years a lot of time in virtual commissioning, and the combination is the last 3 years to not bring the virtual commissioning to USD, more the pick the power from the USD to the combination of the virtual commissioning. So, and in the last time, I developed a lot of extensions like an behavior studio. So that's a powerful feature that allows the user to select in behavior. So you load the 3D cell and then you select behavior, and then it's running. It's do the behavior like collision detection or moving objects. So you have a library of behaviors. And so I can explain more about the virtual commissioning stuff. And for all of you, that's a little bit commercial. You can follow me on LinkedIn. I pasted a lot of videos or YouTube with NVIDIA, what I do, what I create. So I share a lot of stuff like on YouTube and LinkedIn.
Yeah.
Just post the link to the chat and
I will do
you can
that.
follow it. Yes.
Mhm. Maybe just if you want to, these are topics are a little advanced, I'd say. If you do the first steps of the learning path, I'd say, and follow it through and do the examples and see how far you come and just bring your questions next time.
One suggestion: if you're ambitious and you have your whole weekend time, there's an OpenUSD in 1 weekend course.
That's
It
also
is
very good. Yeah,
very good, but it's
yeah.
also ambitious to get it done in 2 days.
But still, that's a good thing. Yeah, that's
I posted the link in the chat there.
that's awesome. Yeah. Mm-hmm.
The LinkedIn link is down currently. I cannot paste the LinkedIn, but you can search my name, and normally you can find me quickly.
And if we don't, we just do it like next time.
Perfect. So I must leave. Thank you. Have a nice weekend.
Right. You too. Thanks for joining. And yeah, also the others, have a nice weekend and thanks for participation. Yeah.
Bye-bye.
Thank you so much.
So,
Thank
Have
you.
a nice
Bye.
weekend, guys.
Bye.
Bye.